want to send you this? Or do you want it now?
Yeah, right there. Near my keyboard.
What's the name of that again?
Example problem? Yeah, it should be before the problem set.
Okay, yeah. Oh, yeah.
All right. So we've got this situation where we're from the ground's frame of reference. The train is moving to the right, the worker is moving to the left, and we're asked to switch from that to the train's frame of reference. What are the three velocities? So let's see. The three things that will be moving are the train, the worker, and then we need to think of it as the earth or the guy standing looking at the track, right? So I would say that the big first thing is to show that you understand some things about relative motion. So in the Y, I would start off with something like, how about all motion depends on your frame of reference. And then go on to saying both the speed and direction will change with the frame of reference. Does that make sense? I haven't really tied it into this problem, though. Let's see. Maybe even say something as simple as in the train's frame of reference, the earth will move. Horrible handwriting right there, but all right. So remember, I need something that ties it to this exact problem, so it's not just a general statement. Okay? Then I need to start with valid physics equations. So let's see. Relative motion. So VAB equals negative VBA. And VAC equals VAB plus VBC. Those are right directly from our equation sheet.
And where can you get this?
Yeah, you always have an equation sheet, no matter what. All right. So now, just kind of looking at, hey, what did they tell me? They gave me the velocity of the train with respect to the earth, the velocity of the worker with respect to the earth, and they actually gave me the velocity of the earth with respect to the earth, but we know that's always 0. So what would be, and then they want to know all three velocities from the train. So they gave me the velocity of the train with respect to the earth as, is it okay if I call to the right positive?
Yeah.
Okay, what is that, plus 15? Plus 15 meters per second. They gave me the velocity of the worker with respect to the earth, negative 1.2 meters per second, right? And they want to know what's the velocity of the train with respect to the train. Oh, that one's straightforward. What's the velocity of the train with respect to 0? No units because it's 0. Velocity of the earth with respect to the train. And they also want to know the velocity of the worker with respect to the train. Right? Just kind of taking the problem and now putting it in the language of math. Yes? Oh, wait a minute. Earth to train. I know train to Earth, and so Earth to train would just be the opposite of that one, right? So velocity of Earth to train is negative of positive 15 meters per second, which means it's just negative 15 meters per second. Right? Probably not on that one. On the next one, if you didn't show like how you got it, I probably would. But that one's kind of, when they're obvious, they're obvious.
Is this part of the test on paper?
Yes. I thought about having you do it and then take pictures and upload it, and it's getting a little too complicated. So yeah, we're actually using paper for the first time this year. I know, it's shocking. It is. Yeah, I wasted a whole flex block today watching a copier. It was fun. All right, let's see. We got that. We need the velocity of the worker with respect to the train. Well, that's going to be the velocity of the worker with respect to something plus the velocity of that thing with respect to the train. Remember, I want those two. Oh, we know the worker with the earth, right? And we know the earth with the train. Yeah. So now we can plug. Worker with the earth is negative 1.2 meters per second, plus earth to train is negative 15 meters per second, which means the velocity of the worker with respect to the train is negative 16.2 meters per second. Oh, I should be boxing these, right? Box. Box. And box. How do we do? Yeah?
Can I ask like a MOPS question? It's like similar to this.
Alright. So we got object 1 starts at 25 meters and moves with a velocity of negative 5.1 meters per second. 2 starts at 13 and moves directly towards object 1. So if it's moving towards object 1, it must have a positive velocity, right? And the two objects collide 0.62 seconds after starting. They want to know what's the velocity of object 2 and what is the position when they collide. All right. So in my y, I would start off by drawing a diagram. And I'm going to assume this direction is positive. And over here is 0 meters. Here's 13 meters. Here's 25 meters. I know this is object 1, it's moving that way. Object 2 is moving that way. Right? And then I would say something like, to meet the objects must be in the same place at same time. Right? That's what it means to me. Yeah? Okay. And I'd probably put something in there to show I understood, But I think the diagram shows a lot, and then you're saying, kind of what your criteria is. So maybe a line about, the meeting point will be between the two objects or something like that, just to kind of show that you're thinking further into the problem. So. All right, so then switching to my how, I would start off with my general equation, you know, where I end up is where I started, d naught, and the velocity I was moving with and the time I moved for, right? That's from the equation sheet there. So, for object 2, let's say I end up at D, I start at 13 meters, I'm moving at some velocity to, and I move for 0.62 seconds. Right? That's object number 2. For object number 1, I end up at D, I start at 25 meters. I move at negative, excellent, thank you, negative 5.1. And I move for 0.62 seconds. So even if I wasn't given the time, I could figure, you know, I'd have 2 equations with 2 unknowns, right? And I could solve them. But nicely, they gave me the time also. And so, I could figure out D right away from number 1, right? Then substitute that into the other one to find V. Just because they ask you for the answers in a certain order, don't think you have to do them in that order. You may answer their part B and then answer A. Right. So I think sometimes it's just what comes up in the problem writer's mind. So D is going to end up being, I don't know, sorry, grab my calculator. Yes, sir.
So if I already submitted one, but I just redid a bunch and did them all gold, should I resubmit like a new one because I can't unsubmit the old one?
Yep, you should. It's going to make my life harder and harder. That's perfectly okay. Of course. Not 6.2, 0.62. I got 21.838 meters. So my answer would be they meet at 21.8 meters. Right? Now, if the computer asks for 2 sig figs, I put in 22 meters. Right? But on the test, always give 3 sig figs. So, and then I can put that in over here. 21.838 meters equals 13 meters plus V2, 0.62 seconds, and solve for V2. Let's see, minus 13 divided by 0.62, and I get 14.2 meters per second. Oh good, I got a positive number because that's what I had said before, right? The velocity is going to be positive. So yay. So I might even want to show that, especially if they ask me to solve for velocity. I should have kept that on there. I'd want to put the positive on there. That make sense?
Yeah. I mean, I didn't write the equation until like 5 minutes ago.
Yeah. Yeah, and that's why, you know, the rubric is to help you organize things. Because as the problems become more complicated, if you get in that habit, it will actually make it easier on you. Yeah.